Hello all, welcome to today's class. Today is file IO operations. We'll see how files are handled in C and how to write a file content into the file and access the content from the file, and what are the different operations we can see to use and manipulate the files across the file directories. And also we'll see what are the basic operations that can be performed using this file, like file open, file read, etc. Next, after that, there are two types of files, which is text file and binary file. How we can use to open and do these file operations on the text file and binaries file as well. And these some programs and usage, and we can handle and what type of errors we can see while handling these files. So let's start this. So basics of file handling in C. The file handling in C is a process where we can create the new file, open, read, write, and close the file with C instructions. This C language provides different functions such as file open, file write, file read, file seek, file printf. So this file open can be represented as the inbuilt function fopen, file write fwrite, file read fread, and file seek is fseek, and file print. If you want to print entire file directory, then you have to use fprintf. And there are several others as well. We will see as slides progress. This is used to perform input and output operations from different file operations in your current directory on file performation. In the first place, why we need to handle file handling in C? Why we need to deal these handlings in file? There are four major uses that we can see for this file handling. First one is reusability. The reusability is if you have a data that is stored in 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 the format of text and binary file. If you want to access the particular data in that file, or if you want to update, modify, or delete particular string or particular instruction in that file, you can do this using manually as well. But if you have many changes that has to be incorporated in the file, then it is very difficult to change it, right? So for that purpose, this can be used to handle through C programming, where you can access the file and read the contents from the file, and wherever you need to modify, those has so can be modified with high reusability. The same thing can be performed across all the files in any directories. That is the first one. Next one is a portability. So you can port. We can see if you want to change the file format from one to another, like the text file to binary file to the text file. So without losing any data, these files can be transferred from one form to another form using this C code. The risk of flawless of changing from one to another in some files, right? When you change the file type, the content of it gets modified, and the nature of the content inside the file might be also changed. But in C programming, it won't be like that. Whatever there in the data, that will be as it is changed and replicated with the same input file, wherein which it changes from original file to the reverted file. There is second one, portability. So you can port a number of files in any formats. Next one is efficiency. So if you have large amount of inputs, right, you need to write some programs. If you need to access a file to handle these instructions, large amount of instructions, then it will be very easy to access, and chances of getting errors are also very less. So you are having more efficient manner of handling these things when you are dealing with file operations. The next one is storage capacity. This file allows you to store large amount of data without having any restrictions to store the file. If you are having anything that is having text file document, if you want to store that, it can have n number of data inside it. So you can store a large number of data and perform any operation simultaneously on that particular file without worrying about the size. Let's see how many types, as I said you, right? The file handlings can handle in C with two types, which is text file and binary file. These files are classified with respect to the file storage of the data. One is a text file. Let's see what it is and how it can be accessed. A text file contains data in the form of ASCII character. So every character inside this text file is considered as ASCII characters. ASCII is a standard representation which will be understood by machine hardware and the program, and is usually used to store the stream of characters. So we have data type in C, right? We have character data type, where in which whatever the content present in this file will be stored across this medium. Now each line, whenever it traverses over the line by line, once it starts with the line, ends with the line, that particular line, it stores with a new line character /n. We know, right? These are called a format specifiers, which is /n for the new line, example /t for giving space between two lines. It can be read or written in the text editor. If you want to append some data into the file, you can do it. Or if you want to read some data from the file, you can also, that is also a possibility. Stored with txt. Extension means it's a text file and the content stored in that file across this text files. So whatever contents are there inside the file will be read as ASCII data. Let's say in English or whatever language, the text file can be read it from that. This text file can also use to store the source code as well. Let's say you have a program, C program .c extension file, but you did not keep it as .c extension file. You kept it as .txt file, and the code is stored inside this text file. There also you can, open and retrieve the data from this text file, and you can access the data. And even if you want to change any line of the code, you just change it and save the file. Next file type is binary files. The binary files contain the binaries from zeros or ones, either 0 or 1. It doesn't have any other thing. So it just toggles between 0 and 1. 0 is high position, 0 is low position, 1 is high position. Instead of ASCII characters will have several data types, data values in it. So instead of that, all this data gets traversed or converted in binary format, which is 0 and 1. They contain this data and stored in the similar manner. How this ASCII character stored in the file, right? The same way, this binary format data gets stored in a similar manner. The binary files can be created only from or within a program that these contents are being changed or monitored once you read the program. These are very more secure and people won't understand what it is having until unless we decode the file. And it is very readable also. These are generally in .bin file format extension. So in C, we can handle .txt format extension and .bin file format extension. And what are the file operations we can perform in C? An inbuilt file operations. C file operation can be referred below format. You can use the function to open file. Now, what are the different types of formats you can open the data in this file? So you can open with A++, W, W++. A is nothing but append data. If you want to read or read plus add new data to the existing file without removing entire data from the file, that format is A. If you want to perform write on the new text file or a binary file, then you have to use W. Existing file can be used from fopen. This function is used just pass file name in this function you can able to open the file and read the content from it. Now reading from the file is fscanf and or f. These are the two functions which help us to read the information from the file. Next, in writing information to the file. So that is fprintf and fputs. These are the two functions which will help you to write the content into the file. If you want to move the file to a specific location, then you have to use this fseek and rewind. Fseek is to move from the specific location. It will be moved. Once these operations are done, you want to close the file with a safe exit, right? Otherwise, junk data will be, if you keep the file as open, the junk data will be keeping appending into the file, and it will convert as a meaningless file. So that is the reason once you open, perform any actions, whatever actions that are needed at the end, it's a standard approach to close the file. To close the file, you have to use fclose. So these are the various inbuilt functions that will be used in C. I repeat it again: fopen, fgets, fscanf, fprintf, fputs, and to move a specific location, fseek, rewind, and close the file, fclose. These are the files that will be used. Next topic is file pointers in C. What is a file pointer in C? A file pointer is a reference to a particular position in the open file. Let's say you open the file and it has 100 lines of code or 100 lines of string data, text data, which has ASCII format. If you want to jump directly to the 66th line, or if you want to jump directly to the 99th line, then how to do it? You cannot traverse a line by line or read and iterate each line and increment the line number. That is not the right way, right? So to avoid that, you use this concept called file pointer. Using this file pointer, you can directly reference to a particular position in an open file. Where it is used, basically, it is used to, perform all the file operations. This file pointer again perform all the file operations like read, write, close, move, wherever it is needed. So how this, how these functions get accessed in the file menu in your active file. So you have to do something called stdio.h header file. So these functions are present in stdio.h header file. So you just have to include this stdio.h header file inside your code and the inclusion list. Then you can access all this data from your header location. Now, what is the syntax to use this file pointer? The file pointer as simple, the file and the pointer name. The file pointer is used almost to perform all the file operations in C. If you observe right here, the file is a keyword. Next one, we'll see one by one how to open a file in C. For opening the file in C, fopen, as we discussed previously, fopen function is used to, open the file. So what is the argument that it takes? It's very important, right? The syntax and accessing mode of this file. Syntax is fopen. The argument of it is a file name and what mode you want to access this file. Let's say you want to append mode, you want to open mode, or a write mode, read mode, whatever modes you need, that you have to pass. So the file name is the name of the file. Let's say you are in the same working directory and file is present in the same working directory. Then you just keep this file name, just pass the file name and pass the access mode, whatever way you want to operate the file. That works. Let's say you in your current working directory, your file is not there, the text file or binary file. Then you have to give absolute path from where the file is present. Until unless you give that absolute path, or you just give, you're not giving the absolute path, you are giving just the file name, then it will throw error. What kind of error you will get? You will get file not found, because the compiler checks for that particular file name in your directory. It will always check the current working directory, the file name. If you are not giving the path, just giving the file name, it will see, it won't able to see the file present inside that working directory, right? Then it will throw you a file not found error. If you give the absolute path for that particular file, then the compiler will go to that particular location and able to access the file. Now, once you does this, right, what is the return code or return type that fopen function gives? It's very important. One is it will show if the file is opened successfully, right? Then it returns file pointer to it. If the file is not opened successfully, it returns null pointer. Null means it has nothing, zero. So that is a check. If file is open properly, then file pointer will hold all the content present inside that file. So that file pointer will access all the content present inside the file. If file is open properly. Not open, then as simple as that, it will throw an error stating that a null pointer. We should understand it has some difficulties to access that file. Now, what are the different file opening modes in C? So we'll see what are the different file opening modes. These modes are nothing but these are access modes. How you want to, open the file and perform actions on top of the file. So why these are needed? These are needed because this is one of the argument that needs to be passed in fopen function. So let's see this table and understand what are the available types that are present for the file open. I think it's not visible properly. Let me, zoom it a bit. Yep. So the access type is R. If we give R in fopen, then what will happen is it just reads the memory, like reads the file and gives the file pointer to the variable. That's it. It does nothing. If you give RB, second one, which is RB is nothing but open the file and read the file in binary mode. If you're able to open the file, then very good. It gives a function pointer which will have binary format, either zeros or ones. If it is not able to read it, then you will get null pointer again. Next, W mode. W mode is nothing but you are opening a file which is a text file for writing content. If it is already there, the file is already present in your working directory, then what will happen is it will override the file. If it is not there, it will create a new file and give the function pointer to it. If it is not able to do any operation as mentioned, then it gives the null pointer. Next is WB. WB, as it said, again the same thing, but all these operations can be performed on binary file. So it will open a new file if it is not there. If it is there, it will override the file, the binary file, and just create it. Next is A. A is nothing but it just loads into a memory and sets up a pointer and points to the last character where it is open. The reason for that is from the last character, if you want to write any new data inside the text file, it should start from the last character, right? At the end of the file, the last character is nothing but end of the file. So if you open in A format, the text file will be open and the file pointer will go to the last end of the file, last character. After that only the data gets allocated. Next is AB. AB is nothing but append in binary mode. So binary data gets appended in a binary file. So again the same thing. If you open in AB mode, then the last character present in the text document gets be loaded. and it gets created. After that, if you want to add any new content to that file, you just import the data. Next is R plus. R plus is very useful and interesting uh, uh, you know content access type. So what it does is it searches for the file and it opens and it loads into the memory and points to the pointer. But what is meant by plus here? The plus represents the file pointer to be opened successfully and it returns in extensive permissions. If you are having any permissions like lock functionality, or a user has to, only particular user has to access the file, then it won't be able to access. Same thing, RB plus represents everything like RB, but extensive permission will be there. W plus also same and WB plus also same. A plus also same, AP plus also same. But with extended feature we'll have. Moving to the next one, we'll see some examples of this file programs. The first program, whatever you are seeing, is opening a file. A sample C code to open a file. So first one is stdio.h library and stdlib.h, standard input type output header file and standard library.header file. These two inclusions we have to keep in our file. So in main function, first, while doing any file accessing operation programming, you have to use a file pointer. A file pointer can be declared using a keyword called file, and the pointer in C is the same. Just the keyword states that it's a file pointer. Just a star and the pointer name. So this pointer is equal to f open and the file name and the access mode. Here I am using R. R is nothing but read mode. So the file name.txt is a file which is present in the local directory. So that is the reason I used it. Once if it is open properly, then what happened? The file pointer will have fptr data in it. If it is not able to open it, then you will get a null pointer. That's where I have defined here. If file pointer is null, then the file is not open, program will exit. And with return code exit 0. Exit 0 is a special function where it will force exit. It won't execute any other instruction in the code. You just exit from the loop. Next one, how to create a file in C. If you want to create a file, then what you have to do? Again, declare the file pointer. File pointer is mandatory whenever you are doing any operations on file. How to create a file pointer? A file is a keyword and star fptr, whatever name you want to give, star fptr or star new, whatever, just a pointer. Okay, that is the name of the file pointer. Fptr is equal to f open of file name comma access mode. Here, to create a new file, you have to use w. As I said, if the file is already there, it just overwrites the file. If it is file not there in the current working directory, it creates a new file and writes the data into it. If it is able to open the file in the current working directory, then the content gets accessed and assigned to this file pointer and able to create the file successfully. If it is not able to create, then it provides a null pointer. The file is throws an error stating that the file is not open and program will exit now, and it's a force exit. Next one is program to create a file, write in it, and after writing is done, you have to close the file as well. So I have data file pointer. I want to write this content to a file. I just created fopen and one dummy file. Once it is open, then it is open successfully, then what I will do is I'll take this buffer and calculate if this buffer length is not 0. If it is 0 means it's an empty buffer, right? So you have to write something to the data means it should be greater than 0. At least one character has to be there. So as I said, fputs or fprintf is a function which is used to write the data inside the file. So fputs buffer data and file pointer. If you give pass the argument, then it writes the data in it. So every instruction, every line it will write, and after that you want a new line, right? You don't want to clumsy the data. You just want a new line. For that, you have to give format specifier /n of the file pointer. File pointer you have to give every time in the argument when you do this file operation. The reason is that is the file pointer will have access to that file. That is the reason you have to pass every time. Once this data is done, write all the content, then you want to close the file using fclose. Once that is done, you can able to see file open, data is writing successfully, and file is closed. Next one is you open the file, read it, and close the file with a data buffer. But that data buffer here it is somewhat different. So you have the data buffer ready, and you are asking what is there in existing file already. So already previously it is there written, right? That file you are asking to show and print to the end user. So that's why first you open in read mode, and once it is open you pass gets. Previously it puts, right? You want to append the data, or then that is the reason you kept it as puts. But here you want to get the data from the file. That is the reason you use fgets. Fgets, again the buffer, what is the size, how much data you want to read from the file, and then what is the file pointer. Once you get it, you get and store fgets. At the end of fgets, the data gets copied, 50 bytes of data gets copied into this buffer. You can print that buffer. So till here, we have done with file IO instructions. Rest of the time of the class, we can go with some programs in C. I have set of programs that are being frequently asked in interviews. So let's go one by one. Write a program to check whether the number is prime or not. If it is a prime number or not. First, you want to check the functionality of prime. What is prime? Prime is nothing but if the number is divisible by 2, then it's a prime number. If it is not divisible by 2, then it's not a prime number. Either divisible by 2 or itself. So you take a number now, integer n is equal to 91. I have taken one flag to update the status. So this is a number 91. So what I will do now, integer, I will iterate for loop, and while iterating this for loop, I'll divide half of it. So I'll iterate, I don't want to iterate all number, right? So I just iterates from this number to half of its number. For the purpose, I is equal to 2 to I less than or equal to n by 2. So if I iterate half the function, the time complexity just computes for half of the algorithm, not for the total. If for half of the algorithm, if we able to prove it as prime number, then it is a prime. If it is not a prime number, so in the given 91 is not a prime number here, right? Let us see program to calculate compound interest. So the compound interest needs some formulae, mathematical formulae, right? For this mathematical formulae, we have a inbuilt library which is math.h header file. This will have a functions that are being used for this code. I use that library. Now I have two variables. One is double principal amount and the rate of interest and the time. The formula we know, right? Compound interest. PTR by 100 is simple interest. PNR. Here PNR is nothing but principal N is the number of duration. With respect to that, we need the principal power, which is 1 plus R by 100. R is nothing but the rate of interest at the time. So we will just calculate what is the amount and what is the principal that is getting calculated previously. If you just subtract it, then that is the compound interest. So here I want to calculate the power of this, right? For that purpose only, I used POW function. POW is function is an inbuilt function used to calculate the power of the value. So I get the answer as 714.83. Very famous question in C interview. Write a program in C to swap the values of two variables without using any extra variable. Swapping two variables without using extra value. You cannot take, let's say you are having XY, two variables. You cannot use Z or any other variable to swap X value to Y value to X. So for that purpose, we use small technique here, which is I take two variables, X is equal to 10, Y is equal to 20. Now how swapping works? Swapping works is X is equal to X plus Y is equal to X minus Y, X is equal to X minus Y. If you add both of it, right, then you'll get X. If you add both of it, then you'll get Y. This is the logic we follow. X is equal to, first I will add X plus Y. I'll just sum up whatever the X it has. I'll just subtract whatever Y it has. Then for X, I will subtract whatever Y it has. So what will happen is at the end of time, you'll get 10 plus 20, 30. 30 minus 10 is 20. So X will have 20. Same logic I will apply for Y also. 10 minus 20 is 10. So I will apply that logic to Y. So here 10 comma 20 is initial input. Now output is 20 comma 10. Write a program to replace all zeros with one number. You want to just change all zeros with one number, right? So now I take one number, n is equal to 1,02,301. So answer is a flag which is 0, 1 is a flag which is 0. Now what I have to do, I have to just replace wherever 1 is there, I have to replace with 0. I just take the number and check if it is not 0. Goes inside and find out the remainder of it with 10. So what will happen if you find the remainder of it 10, then that means it's a even number. If it is not 10, then it's an odd number. So for the even number, the answer is equal to answer plus 1 power 10 comma the iteration number. If the iteration is not able to increase, then you will, it is not, having 0. It is having 1. So you'll just take it and, append to the data and, increment the I function. Again, this loop will come. So when this will exit, this exit only when it is not equal to 0. That means once it goes to 0, then only it will come. So how it is reducing the number is getting reduced in this instruction. So for every instruction, it just check this number and goes. So very big question arises for everyone. Why we are doing this modulo 10? The reason for that is if you want to replace 0 to 1, that means zeros will come only in 10th digit, right? At the end, if you keep 0, that is units place. Units place 0 is fine. But at the tens place, every tens place, you have to change the order, right? That is the reason we have used 10 here. Write a program to convert a binary number into a decimal number. So very simple. You are given with a binary number, which is 8421 code. You want to change the data. So you have to initialize the value A with 1. After that, the answer is 0. This is a flag basically. Now, with a given number, if it is not equal to 0, then what you have to do is the answer is equal to answer plus n percentage 10 into A. What we are doing here is your answer flag, if it is the given number divided by 10 and it has a remainder, then that remainder you multiply with 1. let's say your remainder is 0, then everything will be 0. So you left with 1. Flag left with 1. Now n is again modulo divisible by 10. So after that you just multiplied with 2. By this time, why we are multiplying with 2 is basically, so in decimal to binary, decimal will have 10 digits, binary will have 2 digits. So that is the reason we are dividing with 10 here. Here to convert to binary, we are multiplying with 2. For every 2 digits, we have to change either 0 position or 1 position. Write a program to check if the year is leap year or not. It's very simple. If it is a leap year, that means it's a multiple of 4 or multiple of 100 or multiple of 400, right? So you just use a if condition, if else if and else. If it is able to divide the remainder of the number divisible by 400, 100 and 4, the remainder is coming 0, then it's a leap year. If it is not coming 0, then it's a not leap year. It's very simple. So this is a leap year function we have written. And now we will do a function calls and pass the argument one number. This function takes a number in the form of integer. Just take the number, calculate and find the reminders. If the remainder is satisfying with zeros for 400, 104, then it's a leap year. If it's not, an else part will comes into picture and it's not a leap year. Past. Write a program to factorial a number. How to find the factorial of a number? So first of all, factorial means if you want to find out 5 factorial, you just have to decrement one by one and multiply the numbers. So 5 factorial means 5 into 4 into 3 into 2 into 1. That is a factorial. You just create one factorial function with passing a number in it as an argument. Now you use an answer variable which is 1. This is a flag basically. For int I is equal to 1 and I less than n. Now you will iterate every number of the n and you multiply that number to this, so that it gets multiplied and you will get the factorial, obviously. Now the factorial main in factorial, this is for iteration one by one. Now factorial function is if the given number is 1, then this function is we have written in form of recursive function. So n into n factorial of n minus 1. So if you pass 10, that means here it will go 10 into factorial minus 10 minus 1. Again factorial function is this. So again 9 will come. Again 10 into 9 into 8. Like that every iteration you will get. But if you see here, right, the main function is a function. So in here n is equal to 13. We have to do factorial iteration first. What is meant of factorial iteration? The function call will happen here and 13 will be holded here. So now here for unsigned long int of answer is 1. So I is equal to 1. I less than 13. So 1 less than or equal to 13 and I plus plus. 1 less than or equal to 13 is true, right? 1 is less than 13, right? So that's the reason it will go inside. So answer is 1. 1 into 1. True. Next, 2 increments. It's a post increment, right? So 1 increments with 2. So now it goes to 2 and checks the condition 2 less than or equal to 13, which is also true again, and just increment again. So 1 into 2, like that 3, 4, 5, 6, till 13 it will go. 1 into 2 into 3 into 4 into 5 into 6, 7, 8, 9, 10, 11, 12, 13. That is a factorial iteration. You'll get the factorial iteration. This is one way to do. And second way is using recursion. So in the recursion, same way, take 13 and 13 into again 12, passing 12, again 11, again. Like that, calling the same function again and again, you'll get the answer. Once when this loop breaks only when it's equal to 0. So it shows you the return data as 1. Force exit again. Next one is write a program to check if the number is an Armstrong number or not. So if it's an Armstrong number, how to do it? Whether it's an Armstrong number or not. So here we used a function which is nothing but x raised to the power y. You pass x number and y number. You just calculate what is the x raised to power y, and you will multiply the half of the numbers both. So it is x comma y by 2 and x comma y by 2 again, and you multiply it and you return the value. Next is to calculate the order of the number. You just see what is the order of that number. In the first place, whether a number is given to you is Armstrong or not. So for that purpose, you use is Armstrong function. Now n is equal to order of x. So it will call the previous function call and calculate and assign the value to the n. After that, it has while loop till temp is true. The temp is true means temp is till greater than 1, it is true. If it is goes to 0, temp will be false. So till that purpose, we will iterate while loop every time and calculate the remainder. And once that remainder is calculated, it calculates the power and add the sum to it. If this is satisfied, then the return sum is given number itself. Then that is called Armstrong number. This is the logic. So let's take x is equal to 120. We just pass that number 120 and this function call will happen and this iterative approach will done. Once that is done, if you see the given pass number is the same, then it returns 1. If it returns 1, that means this given number 120 is an Armstrong number. If it is not 1, then it not has passed to the 0. For the next number 1634, again it will be passed and iterates one by one half of the number and power of it. Once you get the same number, then it will be passed to the same number. So in the first case, it is false. 120 is not Armstrong number. Next number is an Armstrong number. This is very simple. Let's go to next one, quadratic number. This is very, important. Writing a program to reverse of a number. How you can reverse the number? First one is, if you want to reverse a number, what will happen? Let's say you have 1, 2, 3. So you want to reverse a number means 1, 2, 3 will change to 3 to 1. Now before going to that, we'll go to the main function. Int n is equal to the given number is this. You want to reverse the number, what you have to do? 15942 will be changed to 24951, right? And the function call, I'm using the function call here, reverse iteration function. I have implemented this in two ways. One is using normal approach, second one is using recursive approach. In normal approach, the function call will have over here, and I have taken a flag answer is equal to 0. After that, again the same approach like previous problem. I'll take n not equal to 0 till n not equal to 0. The loop gets iterated. If n is equal to 0, then loop breaks, because while loop iterates only when it is true. If it is false, it breaks. So I have taken a flag and multiplied it with 10 and n percentage 10 and n divided by 10. Why we have taken 10? Very simple. So all these digits starts with units, tens, hundreds, thousands, like that, right? So for every one digit to another digit, it's just multiple of 10. So that is the reason we have taken 10. So for the first number to the next number, this gets iterated and it will showcases the number. This is one approach. Second approach is using recursive approach. It's very simple. Follows the same approach. Answer into 10 plus modulo of 10 of the given number. So you'll get at the end 15942. After executing from the first function, you will get 24951. And then after executing the second function, 24951 will get reversed again, and you'll get the initial number 15942. This is a common question asked in every interview in C. Approach is same. The same question will be asked in Python, Java, C++, everywhere. Same concept they will ask. Reverse of a number using recursive approach or normal approach, whatever way you like basically. But point to be noted here is this approach, you have to remember the approach, because in any coding language, be it C, C++, Python or Java, approach is same. How you will write the code matters, right? If you know the approach properly, then you can able to code in any language. Next one, checking palindrome. Previously we see that is given the palindrome and not palindrome scenario. Armstrong also we did. Now I'm skipping that. Next one, write a C program to check if two numbers are equal without using bitwise operator. It's very interesting question. So if two numbers are equal, what is the check? Without using bitwise operator, you have to check it, right? So very simple. You have to use two numbers and just perform XOR. What is meant by XOR? If two numbers are XOR means if both numbers are equal, then it is equal. If both numbers are not equal, then it is not equal. As simple as that. That means if A is true and B is true, then only the light glows, which is 1 again. If A is false, B is false, then only false. In all other condition, 1001 condition, it is false again. Both 11 condition and 00 condition only, it is true. So using that logic, we will use here XOR. So X or symbol of Y gives you, if the both numbers are same, then it gives 1. If both numbers are not same, then it gives 0. Based on that, if else condition gets executed. And this is also very, interesting question. Write a C program to find GCD of two numbers. GCD is greatest common the greatest common divisible. So if you are having two numbers, you just have to find what is a common divisible with a greater number. Let's say 4 and 6 is there. 1 is also divisible, 2 is also divisible, 2 to the 4, 2 3 is a 6. So you cannot say 1 is a common greatest common divisible, because 2 is also there. So in that 1 and 2, what is a big number? Big number is 2. So 2 is the answer here. So you understood the logic, right? You just have to find out what are the multiple factors for the given numbers and see where the factors are matching. After that, list down all the factors that are getting matched, and in that you just take maximum number. Next one is LCM, least common multiple. LCM is nothing but least common multiple. So it's very, very simple. What you have to do is, let's show you from the main function. Main function, I have two numbers, n and m. So I'll use a function called LCM, passing this n and m to it. You go to LCM function. So your LCM function is this. So it takes arguments L and M. If the given number and number 1 and number 2 both are equal to 1, and or condition, that means 1 and 1, then only true. If true, if both are true, then only true. If anything is not true, then that is false. 1 and 1 condition only true. 1 0 0 1 is false, and 0 0 is also false. That's the reason. If both numbers are equal, then that is the true. Let's take a sample number. If that sample number, the min number of it is less than the given numbers, both of the numbers, then it is also true. So you have to check all these iterations. Once you get this minimum number, you have to output that minimum number. Now the next program is you want to find out maximum and minimum numbers of the two numbers in the given question using loops or condition formatting. It's very simple. Take two numbers and you have to return minimum of it, right? You just have to find out addition of two numbers. A plus B plus ABS is nothing but absolute of a given number. So absolute of A minus B by 2. So you just find out the maximum number of both of it. Minimum number is subtraction of both of it. That is the absolute minimum number of both of it. So you give 55 and 23. Maximum number is 53. Minimum number is 23. Next, write a program to calculate what is the highest number and what is the lowest number. And find out the natural numbers up to n without using semicolon. So it's a one line instruction and it's pretty simple. So whatever the value user you get from the user, that value take, and it's a natural numbers, right? Natural numbers will have 0 to 9. So till 10, it will have 10 items. It gets iterated. Passing that number, whatever the number it is getting passed, check if it is smaller than that or equal to that. So if user passes 10 or 9, then it's fine till 9. If it's past 10, so 10 is equal to 10 is also okay. You print it and you find out the minimum value of it. Write a program to find out area of the circle. So here we have used define for constants. So the pi value won't be changed, right? You can use two ways. Either use define the variable name pi 3.142 or else you use const and find out the data. So you will see printf area is and you call the function find area with passing the number in it. So area of a circle is pi r square. Very simple, right? Pi into r square. R square you have to use power function, which is present in math header file. So you have to include math header file in your inclusion list. Math.h and power function r comma 2, which is r square, right? So r comma 2. Once you are done with it, you'll get the answer and it's just printed over here. Next, write a program to create a pyramid pattern using C. This is also an interesting questions being asked, and it's very simple. Pyramid pattern is, let's say whatever they are asking, input number is 5 now, right? Pyramid, how the pyramid looks like? Pyramid looks like this, right? Triangle shape. So you'll have one base, and that every incrementing step from the base at the extremes, left and right extreme, you will decrease one. Let's say you are having base of 5 stars, above is 3 stars, above is 2 stars, above is 1 star. It's like that. So you decrease one by one in every step. How that is happen? You just use a for loop. Two iterative for loops you will use. One is for, sorry, three iterative for loops you will use. One is for stars, next is for spacing, another is stars again. So first you will get the base, then you'll use a space iterator, then you use another star again. You'll get like this. Space for empty spaces, star for empty star. So base, space, star, base, space, star. So in every approach, you will subtract the level, right, by 1. So that is this n minus 1. So initial way, you subtract from that given number. So you will get from the base extremes, left extreme and right extreme, you will remove 1 star. You will get the answer. Okay. Same thing again, Pascal. Instead of stars, you will add a number over here. From the larger number, you will add. From the smaller number, you will add by incrementing. From the larger number, you decrease by decrementing. That depends on what the number user is giving to you. If user is giving larger number, then this is a code. So again, it will have two for loops. One is for increment, one is for base, and next number extremes are reduced. And extremes, instead of reducing, we will keep it as ones. And this is source code for it. The Pascal is also same and easy. Reverse. Yeah. Reverse of a number you have seen now. You have seen previously. Now reversing an array. So how you want to reverse an array? This is also just swapping between these array numbers. Bit easy. Let's see. So you have given with an array function array which is 1, 2, 3, 4, 5. Now you call a function called reverse, passing an array and the numbers. It has the size of the array. Now int array comma int n, the size of the array. We passed it. Now swapping function from front and back elements. So I is equal to 0, j is equal to n minus 1, and I less than j, I plus plus, and j minus minus. So we are doing everything in one line. So initialization you are doing here. I is equal to 0 and j is equal to n minus 1. After that, conditional format is I less than j. After that, post incrementing one and decrementing another. So from the extreme front and from the back, you are decrementing. So front index you are considering as I, extreme and index you are considering it as j. You just take the element with first number and element with last number and just swap each other using third variable. Write a program to check the repeating of elements in C. So how you can repeat a duplicate of elements in C. If it has a duplicate number, then you just point out and put the index number. That's it. For this, you need to write extreme ends. You have to calculate from one n to another n. So first number is there, after the second number, after the third number. So the first number to the second number, you have to check. Again, second number to third number, you have to check. Third number to fourth number, you have to check. Let's say in some use cases, right, first number and fifth number will be the same. If you're doing this method, you will miss that first number and fifth number. So you have to be very cautious, not only checking adjacent numbers, you have to check the extreme numbers as well by taking a flag. Next one is write a program to print maximum minimum elements in array. So you are given with an input array. You just have to find out what is the size of an array and take the size of an array and calculate the length of it. The size of an array is given by inbuilt function size of. I'll get the length of the array. So that is nothing but in this current example, it is 6. Now size of the first number. Size of the first number is 15, which is 1. You'll get now size of an array. Now finding small and larger number from an array, you have to pass an argument, array and length of an array. Once it is passed, the function call will happen. So the compiler jumps from here to here. Then after that, you calculate the min number is, you starts with the 0 index is minimum and 0 index is maximum. After that, you increment one by one and you check decrementing one by one. First, you will find the smallest number, then update the flag, then go to the next number. If you see the first number is completed and the next number is smaller than the previous number, then update the flag again with the second number. Like that, you check iterative approach one by one. simultaneously. So you will get the maximum number and minimum number as well. This is also simple question. The simple. This is one more important question. Write a program to find out transport of matrix. So transport of matrix, right? Transpose is nothing but rows and columns gets interchanged. That is called transpose. So you have rows like this and you have columns like this. All rows and corresponding column get changed. It gets interchanged basically. So how we will implement this? Let's look into this problem and why it is important in the first place. We have to understand. So this type of problem, right? Transpose is a matrix problem. Everybody will think like it's a matrix problem and mathematical problem. But we have to understand one thing. This mathematical matrix problem can be used in our real life also. Let's see how it uses in our real life. Let's see you are having some roads in your colony. Now you want to calculate the distance from first building to 15th building and from 15th building to second building and second building to 15th building again. It's like triangle, right? So for that calculation, once you go, in your colony, you just design how many rows and how many columns are there. The distance calculated by this row and column, adjacent distance and diagonal distance. If both the distance are same, then that is your adjacent nearest member in your colony. So that transpose mechanism works in that example. So you take rows and columns as m and n. So you create an array. That array is 1, 1, 1 and 2, 2, 2 and 3, 3, 3. Now you know the dimension, right? The dimension is row into column. So H is 3, row is 3, column is 4. Now you pass into the function transpose. What it does, row should exchange with column, right? So you use two for loops to do that. It's very simple. Ij is a flags, starts with 0, and n and m are the rows and columns, right? You take I less than m, j less than m, and wherever you want to exchange from B to A to B, you change it and assign to the new number. That's it. So Ij gets assigned. So 1, 1, 1, it will come in horizontally, vertically, and 2, 2, 2, vertically, 3, 3, vertically, and 1, 2, 3 comes in horizontally. So this 3 by 4 will be changed to 4 by 3. And this is how your array matrix gets implemented in respect to transpose. It's also simple. This is on the string length, right? Yeah. Write a program to count the number of sum of the numbers in a string. Now you are given with a string. You just have to consider how many numbers are there inside the string. If any numbers are there, add each the number and you have to print the final answer. So first of all, a string cannot be changed into integer. That we know. We can do this using typecasting. But a critical problem here is whatever the string that is having all the characters or literals inside that string may or may not be in numerical numbers. It can have literals also. So the first we have to check whether that is a literal or numerical number. For that, we use a for loop iterator, iterate with every number and every literal character. If it is a string, then very simple, string always ends with /0 in C. So we will check if it is ending with /0 or not. If it is not ending, then only you will process into the for loop. If it is ending, then it won't process into the for loop. In the first step itself, we are removing that. So once you checked it and it is entering into the for loop, that means it's a number. You take the number and convert that literal into ASCII, and from that ASCII you add to that to flag. Here flag is answer, right? You add that to flag. So one by one you do this iterative approach for every literal, you will get the answer. Going to the next, find out the length of the string. It's very simple. Take the string, remove the string pattern, iterate one by one using for loop. Again the same thing. If it ends with 0/0, then it's a string, or else it is the number. Same pattern. Same pattern. Palindrome we know. Permutations also we know. This recursion is important. Yeah. Write a program to calculate the power of a numbers using recursion in C. So here we have to calculate the power of a number. The main function int a is equal to 4, b is equal to 5. Now answer variable is equal to power of a number is power of a comma b. Now power function definition is having here power function. So if you go inside, if second number is always 0, then power is 0 means answer is always 1, right? That is the 1. If power is not 0, then you return the value it as 1. If it is not 0, then you return the power a comma b minus 1 into star a. So one by one you have to change and iterate to it. Going to the next one. People knows, everybody knows, and it's very simple. Highest common factor we know. Highest common factor is the least common factor is there, right? The opposite of it. This is also okay. Simple question. This is another one very important, binary search. If you are given with an array, you want to find out what is the middle number and maximum number using binary search. It's very simple. But first you have to understand the algorithm, then it is okay. Binary search algorithm will tell you will given with the numbers, right? Array of numbers. That numbers, what is the size you have to take? Like let's say you are given with 10 numbers. Size is 10 now. You have to take these 10 numbers and calculate the middle of the numbers. So that middle of the numbers of 10 is 5. So in that fifth position, uh, in the fifth position, you have to start iterating one by one from the fifth position to 0 and fifth position to the last. So left side, right side, you have to go. Once you went to the left side, there is nothing but left search and right search. So you'll see which one is a larger number, which one is a smaller number in the middle range. So copy that number, save that number, and at the end, you just compare both numbers again. You'll get the finally what is the smallest number and what is the largest number. That's what you will do here. So initially we find out the middle path of it. Once you find out the middle path, if the middle path is the same, then that is a middle number. If not, then go to the extreme, left extreme and right extreme and find out. You'll get one by one. We'll search. These are all not needed. Single columns. These are okay. So now you understood how to, see different types of programs, and you have used our class understanding to solve it, right? With the previous lecture. So I'll share this PPTs and, uh, codes file as well. So tomorrow's class, next class, we will deal with some project. Thank you.